Alternative blockchain applications. Some time after implementing the Bitcoin network based on the blockchain technology, alternative applications for this technology have emerged. Namecoin. It was created in 2010 and consists in a decentralized name registration database. In decentralized protocols, a user's identity usually consists of a public domain cryptographic key such as JKSHG5NKSP3DGGK8X6GG5K. In order to be able to establish an interaction between users, a more effective identification system is needed. The blockchain technology allows each user to establish a personalized username and at the same time, by setting it in time, prevents another user from using the same name. Colored coins. The aim of the colored coins is to serve as a protocol that allow people to create their own digital coins or create digital tokens on top of the Bitcoin blockchain. In the colored coins protocol, one issues a new currency by publicly assigning a color to a specific Bitcoin UTXO, and the protocol recursively defines the color of other UTXO to be the same as the color of the inputs that the transaction creating them spent. Some special rules apply in the case of mixed color inputs. Metacoin. The idea behind a metacoin is to have a protocol that lives on top of Bitcoin, using Bitcoin transactions to store metacoin transactions but having a different state transition function. The metacoin protocol cannot prevent invalid metacoin transactions from appearing in the Bitcoin blockchain. This protocol provides an easy mechanism for creating an arbitrary cryptocurrency protocol, potentially with features that cannot be implemented inside of Bitcoin itself, but with a very low development cost since the complexities of mining and networking are already handled by the Bitcoin protocol. Metacoins have been used to implement some classes of financial contracts, name registration and decentralized exchange. As you saw, there are two options for developing blockchain-based applications: building an independent network or building a protocol on top of Bitcoin. The first option requires an independent blockchain with the difficulties involved in building a new protocol and developing it. Also, most applications are not big enough to justify a blockchain of their own, and it can even be counterproductive because some of them need to interact. The second option does not inherit Bitcoin's simplified payment verification. Blockchain-based meta protocols cannot force the blockchain not to include transactions that are not valid within the context of their own protocols. Hence, a fully secure SPV meta protocol implementation would need to backward scan all the way to the beginning of the Bitcoin blockchain to determine whether certain transactions are valid. One of the ways to avoid scanning all the nodes is to establish a central entity that reviews the transactions, but in the concept of a decentralized network it does not make much sense to do this. Scripting. Even without any extensions, the Bitcoin protocol does facilitate a weak version of a concept of smart contracts. UTXO in Bitcoin can be owned not just by a public key, but also by a more complicated script expressed in a simple stack-based programming language. In this paradigm, a transaction pending that UTXO must provide data that satisfies the script. These scripts exist for various additional use cases like secure savings accounts, some merchant escrow situations, and even for cryptocurrency exchange. However, the scripting language as implemented in Bitcoin has several limitations. Lack of Turing completeness. The Bitcoin programming language does not support all computational functions, particularly loops, when you perform a task repeatedly until a condition is met. That's why some types of problems cannot be solved through this language. Value blindness. There is no way for a UTXO script to provide fine-grained control over the amount that can be withdrawn. For example, one powerful use case of an Oracle contract would be a hedging contract, where A and B put in $1,000 worth of BTC and after 30 days the script sends $1,000 worth of BTC to A and the rest to B. This would require an oracle to determine the value of 1 BTC in USD. Lack of state. A UTXO can either be spent or unspent. There is no opportunity for multi-stage contracts or scripts which keep any other internal state beyond that. UTXO can only be used to build simple, one-off contracts and not more complex stateful contracts such as decentralized organizations, and makes meta protocols difficult to implement. Binary state combined with value blindness also mean that another important application, withdrawal limits, is impossible. Blockchain blindness. UTXO are blind to blockchain data such as the nonce, the timestamp and previous block hash. This severely limits applications in gambling and several other categories by depriving the scripting language of a potentially valuable source of randomness.